S360 is a product of prime numbers in index form. Okay, so we need to know our prime numbers. Okay, certainly the collection of the first few. So remember, it starts at 2, then 3, then 5, 7. Okay, and then 11, of course, and 13. Right, that's usually going to be enough for us. Okay, so remember these numbers here have only got two factors exactly. The number one goes into it, and the number itself. That's what makes it prime. So what we do then is, it's up to you which approach you use. You could use this sort of ladder method, or you could use the tree diagram sort of approach, right? The branches approach. So I'm going to do the ladder method here, and I'm going to think about 360 and what divides into it. Now, because it ends in a 0, I know 2 will go into it. Okay, so I'll divide by 2. Okay, and I'll just ask myself then, how many 2's, let's break it down. How many 2's go into 3? But it goes into it once. 2 goes into 3 once with 1 left over. So it's a bit like the bus stop, but upside down, isn't it? 2 into 16 goes 8 times. 2 into 0 goes 0 times. So half of 360 is 180. And I can go again, right, with 2. 2 goes into this, doesn't it, handsomely? So 2 into 1, well, it doesn't go. So carry it. 2 into 18 goes 9 times. Okay. And 2 into 0 doesn't go. Okay. And again, it ends in a 0, so I know 2 goes into it. 2 goes into 9 4 times, doesn't it? Which makes 8. There's 1 left over, and then 2 into 10 goes 5 times. 45. Now, you clearly ends in a 5, yes? You know 5 goes into it. If you go through your 5 times table, it goes into it 9 times. And then when you see 9, you know what goes into 9, don't you? 3, of course. 3 goes into 9 3 times. What goes into 3? Well, 3 is a prime number, so the only number that will go into it that's prime on this side is 3. Okay, so 3 goes into 3 once. So you're left up with this then. Now remember, they do say in index form. So when you write it out, what I'd like you to do is write it out in order first. Okay, so there's 3 lots of 2's, then there's 2 lots of 3's, and then there's a 5. But in index form then, you put it in powers, don't you? Because there's 3 2's, 2 to the power 3, 2 3's, 3 to the power 2, and times 5. Copy says explain why 2 to the power 5 times 3 to the power 4 is not perfect square. When they say here perfect square, what they're saying is this, whatever this comes to, it's not a square number. Okay, that's what they mean by not a perfect square. It's not a square number. Okay, it's just a different way of wording it. Now, why isn't it a square number? Well, in index form here, notice that power here is odd. Okay, because this power 5 is odd. For it to be a square number, we need to have all powers to be even. Okay, so to be square, okay, we could say all powers, not just like one of them, because that's even there, isn't it? All of them, all powers must be even. Okay, and that gets you the mark.